All right, let's have a look here. Consider this function y equals x power 1 over x. Determine the points on the graph where the tangent line is horizontal. Determine the points on the graph where it's positive and negative. Okay, so we can say log y equals 1 over x log x. The derivative is 1 over y dy dx equals minus 1 over x squared log x plus 1 over x squared. And for the derivative to be 0, we'd want this to be 0, which means we'd want log x to be 1. And that would happen when x is e, which is interesting. Now, it does say points on the graph, so there might be a second answer here, but it's not immediately obvious to me where that would be. Let's have a look at the answer. 357. No, it's just the one answer. Yeah, it's just the one answer. So e, and then e power 1 over e. Okay, so that's A, that's correct. And then where is the derivative positive and where is the derivative negative? So the derivative is 1 over x squared, 1 minus log x, and then this is times y, which is x power 1 over x. So I think this isn't going to affect the sign, so we'll forget about this. But this might affect the sign, although we have a problem here when x is... Oh, so x has to be positive, so this isn't going to affect the sign. So it's just going to be with this again. So if you want this to be positive, that means that log x has to be less than 1, which means that x has to be less than e. And then if you want it the other way, it would be the opposite. X is more than e. Okay, so yeah, more than e. Oh, let me think. Positive would mean, yeah, more than e, that's positive. Yeah, yeah. Okay. Okay, let's have a look here now. Implicit. Where are we gone? Okay, I mean exponential. Okay, looks like we're back to tech questions, although I'm confused why this one isn't marked as a tech question, because it clearly is. So maybe we're just to use the calculator. Okay. Let me just zoom out a little bit. Okay. Okay. Let's clear this off. Oops. The formula, complete the following table and then using only the values in the table, determine when the tangent line is horizontal. Okay, well let's try and get out our calculator and fill this in. Okay, let's try. Okay, so sine x over e power x. Okay. Okay. Right. Let's fill this in now. So that's 0.2078 0, 4.71238898, 6.28318530, 7.853981634. Where am I now? Oh, I'm looking at the wrong numbers. Am I? Hang on. Let's try this again. 0. There we go. Okay, I was in. Sorry. 0.2078. I won't put the full number in. 0. 0 minus 0.0008. 0. 0.00038. 0 minus 0.00001, and there's more, and 0. So this, what are we to do here? Use only the values in the table to determine where the tangent line is horizontal. So if we just roughly sketch this out, start at 0, go up to positive, down to 0, down to negative. Yeah. So I think, I'm guessing now because it's in between zeros, it has to be at these points, right? Here, 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 and here. Because then it goes under and then back up to 0. So horizontals would have to be at the points in between, approximately. Maybe not precisely. No, I think it might be actually exact. Do we have answer at the back? No, it's even. It's even. But I guess I could solve it here. Sine x over exponential of x. Whoops, I don't want to graph it. I want to differentiate it and then solve it. Pi over 4. Pi over 4. Oh, so maybe it's not exactly in the middle. Interesting. Interesting. Pi over 4. I don't want to graph it. Let's have a look. First one here is about 1.5. That's about half pi. Oh yeah, that is an answer there. Okay, and then the next one would be like about here and about pi. No, not quite pi. Is it? Would it be 3 pi over 2? About 4.7. Need to. Here, that looks like. See, I feel like this isn't as easy as they're making it out to be without a graph. Because pi over 2 looks good, but then there seems to be another one here, kind of near 4, but not 4.7. You know, I'm not so confident about this one. Not so confident about this one. I feel like the exponential shouldn't matter here so much, so it should just come down to the sine t. So, yeah, I'm not confident with this. It's a pity that I don't have the answer at the back. Okay, I'm just going to leave it here for today. It's a bit of a downer to finish on, but thanks for watching.